The objective of this video is to be able to identify the properties of parallel lines and use them to find find missing angle measures. Now, what does that have to do with this bottom part of the board here? Well, surprise, you've just won the lottery. You're now a multi-millionaire. And you're looking for a new home. All right, you're looking for a new home. You're looking at the ads in the paper, and this one says 10 bedroom, 5 bath, 4 car garage with pool. Sounds good. That's what you're looking for. The inside of this big house is fancy, and the outside is great too. Asking 12 million bucks. Well, it sounds like a nice ad, but what if we took that same house and we put in an ad that looked like this? 10, 5, 4, 10 bedroom, 5 bath, 4 house, still the same thing here, with pool, still the same. But this time, we say the exterior of this mansion is exquisite, while the newly renovated interior contains many luxurious accommodations, conservatively priced at a mere $14 million. Wow, doesn't that sound like a much better house? Do you think they're going to get the extra $2 million with an ad like this? Quite possibly. You see, they're saying the same thing. They're still talking about a big house with lots of great stuff. But using these words, the words say so much more. Each individual word says so much more about that house than just great and good, and things like that. So, in English class, you generally hear all these things. You use these words. Use these words. It's so much better. You try and use a different vocabulary. Well, we're doing that in math too. And in math, sometimes it's ultra important that you work with these bigger vocabulary words because they're really more descriptive than just equal, this, that. So you have to, in math, use these bigger words. For example, we've had a video lesson on angles, and we learned that when you have two lines crossing, the angles directly above and below each other here, or opposite of each other here, are going to be equal. So if we were asked if the measure of angle A is 75 degrees, what does the measure of angle B equal? Well, that part, we should know that the two angles are equal. It's going to be 75 degrees. Justify your answer. Now, I've got some multiple choice options here. A, 75 degrees just 'cause. Do you think you're going to get full credit for that response? No. 75 degrees because they are equal. Okay, you're telling me they're equal, but that's not justifying why they're equal. The measure of angle B is equal to 75 degrees because the measure of angle A is 75 degrees, and they are equal. This goes a little further. It does mention that the measure of angle A is 75 degrees, but that's just restating something from the question. It's basically saying because they're equal. It doesn't justify the answer. To justify it, you have to say the measure of angle B is equal to 75 degrees because the measure of angle A is 75 degrees and they are vertical angles. Using that vertical angles tells us that they are formed by the same two lines, that they are opposites of each other. Saying that word says so much more, and it justifies your answer. If you were just to say these things, it would not work. So it's important you learn the vocabulary behind this and that you understand it completely. To that end, here are a set of parallel lines. Now, when working with parallel lines, not only is the vocabulary important, but some of the symbols are important too. You'll notice that I labeled these two lines with 4 points. BC, that's the name of that line. BC, with a line over it, is telling me line BC. Line DE, writing DE with a line over it, is telling me I'm talking about this line. And putting two lines, kind of looks like the number 11, but they're just two straight up and down lines. Those are telling me that these two lines are parallel. There's another way we can tell the two lines are parallel, just by looking at this. When they put a second set of arrowheads in, see how we got the arrowheads telling us continue off in this direction, the arrowheads continue off in that direction? This second set of arrowheads here is telling me that these two lines are parallel. If there was another set of parallel lines, instead of having just one arrowhead on each of these here, there would be two arrowheads on them to distinguish between which ones are parallel and which ones are not parallel. Now, you got a line coming through these two parallel lines. This line that cuts through is called a transversal. The line that cuts through two parallel lines is called a transversal. Doesn't matter what angle it comes through, it's just a straight line coming through two parallel lines. Stuff that is above or below the set of parallel lines, they're outside of the lines. And anything that's outside is exterior. Remember, the exterior of the home is talking about the outside of the home. So exterior stuff is on the outside. So angles 1 and angle 2, angle 7 and angle 8 are exterior angles. 1 and 2, 7 and 8 are exterior angles. They're outside of the middle here. Those that are in the middle are interior angles. So 3, 4, 5, and 6 are interior angles. And that's part of the vocabulary you need to work with. And we're going to take this a little further here. One thing you've got to realize here is that the math in this section is not that hard. Why? Because it all boils down to, when working with two parallel lines and a transversal, every angle is either equal or supplementary to any other angle. Which means either, if you're given angle 1, you're asked to find the angle, another angle in there, you're either going to say the angle is equal with the justification, or you're going to subtract from 180 and say that they're supplementary. Let's take a look. Here's that same drawing of parallel lines without the extra stuff on there. Now, if I go like this, you'll see that we've got a straight line and two angles that form a straight line. So they add up to 180 degrees. They are supplementary. So are these two. So are these two. So are these two. Anytime you see that straight line being formed, these two angles are supplementary. These two angles are supplementary. These two angles are supplementary. Anytime you see that straight line, the two adjacent angles that form that straight line are supplementary. So, adjacent angles are supplementary. Now, if I take this drawing here and I put it over that axis there. Now if I take this and I drag this down, following the line, I put it over here. Notice how it matches up exactly. Matches up exactly when I drag this down like that. Which means that this angle is equal to this angle. And this angle is equal to this angle. And this angle is equal to that angle. And that angle is equal to that angle. That's a property of parallel lines of the transversal. And they have a name for this. These angles are known as corresponding angles. Corresponding angles are equal. Angle 1, angle 5 are corresponding. Angle 3, angle 7 are corresponding. 4 and 8 are corresponding. 2 and 6 are corresponding. So when you match those up and you're working with it, you need to justify, you can say they are corresponding angles. Now, vertical angles are equal to. Vertical line, here's two lines crossing. Anytime you have two lines crossing, the angles that are opposite of each other are going to be equal. So 2 and 3 are equal, 1 and 4 are equal, 6 and 7 are equal, 5 and 8 are equal. That shouldn't be a surprise. We've done that before. Then you have something known as alternate interior angles. And there's a reason why I did alternate in purple and interior in green. Because these purple angles, they're interior angles, and they are alternate interior angles. They're not on the same side of the transversal. This is on one side of the transversal, this is on the other side of the transversal. As it turns out, alternate interior angles are equal, which means 3 and 6, the purple numbers, are equal. 4 and 5, the green numbers, are equal. And they are the reason why, the justification is that they are alternate interior angles. All of them are inside, and they're on opposite sides of the transversal. Then you have alternate exterior angles. Well, the exterior, as we said before, is the outside ones. So that'd be 1, 2, 7, and 8. And notice how I set alternate exterior in red and blue. 2 and 7 are alternate exterior angles. 1 and 8 are alternate exterior angles. They're all 4 of those on the outside, so they're all exterior angles. Then when they're on opposite sides of the transversal, this is on the bottom side, that's on the top side. When they're opposite sides of the transversal like that, they are alternate exterior angles. We're going to work with that in class on how to give things. So if I give you any one number, you'll be able to find the other 8 angles. No you-dos on this one. So the key word here is 6. Why 6? Because that's how many boards I used in this video. So in class, if you have the number 6 written in your notes, I know you've watched the video. Thank you.